So, have you ever really stopped to think about how our universe began? I mean, really began? Most of us, right? We just jump to the Big Bang and we picture this massive, fiery explosion in the dark. But what if I told you that picture, that image in your head, is almost completely wrong? Let's get into it and uncover the real story of our universe's origin. Okay, so first things first, we've got to talk about the name. Seriously, the term Big Bang has probably caused more confusion than anything else. It paints this picture in our minds that scientists have been trying to, gently erase for decades.
And this quote, it just nails it. This gets right to the heart of the problem. The Big Bang wasn't an explosion like a bomb going off, and it sure didn't start big. In fact, the entire universe that we can see today was once squished into a space so small it's impossible to imagine.
Now, this is maybe the most important thing to get straight. The Big Bang was not an explosion in space. It was the expansion of space itself. See, there wasn't some big, empty void for things to explode into. The Big Bang was the moment that space-time itself started to stretch and expand, kind of like a fabric being pulled in all directions, carrying all the matter and energy with it.
History has a funny sense of humor. The name Big Bang was actually made up by a guy who hated the theory, an astronomer named Fred Hoyle. He was on a radio show back in 1949 and used the phrase, "this Big Bang idea," to kind of mock it and make it sound silly. But the joke was on him, because as the evidence piled up, the name, as wrong as it was just too catchy, and it stuck for good.
So, this brings up another really good question. If there wasn't one central explosion, then where's the center of the universe, Where's the X that marks the spot where it all began?
And the answer is one of those things that's both simple and totally mind-bending. It happened everywhere. A great way to think about it is to picture the surface of a balloon. Imagine you draw a bunch of dots on it. Now, when you blow up the balloon, every single dot sees all the other dots moving away from it. But is there a center on the surface of the balloon? Nope. Our universe is kinda like that. The expansion happened from every single point in space, all at once.
Okay, so how in the world did we figure all this stuff out? It's a pretty wild story, but the key was actually pretty straightforward. Just look at the universe as it is today, and then hit the rewind button.
It all started back in 1929 with Edwin Hubble. He made this groundbreaking discovery. He saw that the light coming from distant galaxies was stretched out. It was red-shifted. And the really crucial part was that the farther away a galaxy was, the faster it was speeding away from us. This was it. This was the first real proof that our universe is expanding.
Now, once you know that, the logic is kind of impossible to escape. I mean, think about it. If everything is moving apart now, then in the past, everything must have been closer together, right? So if you just keep rewinding that cosmic movie, you eventually get to a moment where everything in the entire universe was squeezed into this unimaginably hot, dense state. And that simple idea, that's the whole foundation of the Big Bang Theory.
All right, now we get to the really wild part. The amount of stuff that happened in just the first few moments of existence is just staggering. The universe we know and love today was literally forged in this crucible of insane energies and timescales that we can barely even comprehend.
Our story starts at what's called the Planck epoch. That's a 10 to the minus 43 seconds. That is a decimal point followed by 42 zeros and then a 1. I mean, it's a slice of time so small it's basically meaningless in human terms. It's the absolute earliest moment our physics can even try to describe.
And at this point, the temperature was just absurd. 10 to the power of 32 degrees Celsius. It was so hot that the basic forces of nature that we know, gravity, electromagnetism, all of it, they were all mushed together into a single superforce. Matter and energy were basically the same thing. Then, in less time than it takes to blink, this crazy chain of events happened. First, a thing called cosmic inflation made the universe balloon out exponentially. Then, as it cooled down just a tiny bit, this hot soup of quarks formed. And this is key. For some reason, matter won out just barely over antimatter. That's why we exist. By the 1-second mark, quarks had teamed up to form the protons and neutrons we know. And by just 3 minutes in, those had fused together to make the first atomic nuclei, basically all the hydrogen and helium that would later become stars.
So yeah, that sounds like a heck of a story, right? But is there any proof? Well, as it turns out, we have something like a photograph, a baby picture of the universe itself. And it confirms all of this with just stunning accuracy. So for the first 380,000 years, the universe was this thick, glowing, opaque fog of plasma. Light couldn't get anywhere. It would just bump into particles and get scattered. But right around that 380,000-year mark, the universe cooled down enough for electrons and nuclei to combine and form actual atoms. And when that happened, suddenly the fog cleared. All that trapped light was set free in this brilliant flash that filled the entire cosmos. And the amazing thing is, that ancient light is still traveling through space today. Because space has expanded so much, that light has been stretched and cooled down into the microwave part of the spectrum. We call it the cosmic microwave background, or the CMB, and it is, quite literally, a snapshot of the universe when it was just an infant.
This CMB is the ultimate proof. It's the smoking gun. It's almost perfectly uniform, which shows us the universe really did start in that hot, dense state. The temperature we measure today is exactly what the Big Bang model predicted it would be. And you see those tiny little ripples and splotches in the picture? Those are the cosmic seeds, the tiny differences in density that over billions of years grew into all the galaxies, stars, and planets. It's just incredible.
But you know what? For everything we figured out, the story is definitely not over. The Big Bang model is unbelievably successful, for sure, but it also points us toward even deeper, weirder mysteries about what reality even is.
Which, of course, leads us all to the ultimate question, right? The one everyone asks. If the Big Bang was the beginning of our universe, what was there before it?
Well, the classic answer used to be a singularity, this theoretical point of infinite density where our laws of physics just completely fall apart. But these days, most physicists don't think of it as a real physical thing. It's more like a signpost that tells us this is where our current theories stop working. It's the edge of our knowledge. And this is leading to a really profound change in how we think about it. A lot of modern theories are now suggesting that the Big Bang wasn't the absolute beginning of everything, but maybe more of a transition. It might have just been the moment when some pre-existing state kicked off the massive expansion that created the universe that we live in today.
And that leaves us with this final, amazing question to chew on. Is our universe a one-off event, a single story? Or is the Big Bang just the first page of our chapter in a much, much larger cosmic book? It's a pretty humbling reminder that as much as we know, the universe's biggest secrets are probably still out there, waiting for us to find them.